Welcome back everyone to this continued discussion on categorical plots. Now we're going to shift our focus onto understanding distribution within categories. And in part 1 we're going to focus on understanding the various plot types and when to use them, and then in part 2 we'll actually code them out with Seaborn. Now we've already explored distribution plots for a single feature, such as a histogram or KDE plot. But what happens if we want to actually compare distributions across categories? For example, previously, we explored the distribution of everyone's salary. We took the entire salary column and then created a histogram of it. But what happens if I want to compare distributions of salaries per a category, such as salaries per level of education? Well, in theory, I could just separate out the data frames themselves and then create a histogram for each of those categories. But what we're soon going to discover is that there are actually better plot types to compare these distributions per category. So essentially what we do for each of these plot types is we separate out by category along an axis and then create the distribution visualization per category. So let's explore what plot types we have available. The main plot types are the box plot, violin plot, swarm plot, and something called the boxen plot, officially known as a letter value plot. Now by far the most common of all these plots is the box plot. So if you get anything out of this lecture, it's fully understanding the box plot. Now, these other plot types, such as violin plot and swarm plot, especially the letter value plot, are less common. So we will learn about them since they are available in Seaborn, but the main plot type that you'll probably see in real life when comparing distributions within categories is the box plot. Let's go ahead and explore understanding all of these plots on the previous salary dataset. Let's begin by talking about the box plot. The box plot displays the distribution of a continuous variable. Now we already know how to display a distribution through the use of something like a histogram. So what makes the box plot so special? Well, really what it's going to visually show you is statistical parameters based off the use of quartiles. So quartiles separate out the data into 4 equal number of data points. So that is to say that 25% of the data points are going to be in the bottom quartile, and 25% of the data points will be in the top quartile. So that means something like the 50th percentile, Q2, is going to be the median. It splits the data in half. So here we can see the box plot on a single feature. So we took all the data points for salary and then visualized them with a box plot. So let's go through each of the visual characteristics here. In the middle, we see we have the box itself. And keep in mind, box plots are sometimes called box and whisker plots because we can see we have these whiskers that extend outside of the box. But focusing within that box, we see a line. And that line is the 50th percentile. It's the median, which means it splits the data in half. So that line looks to be about at the $90,000 salary mark. That means that half of all the salaries are going to be below that line, or to the left of it in this case. So half of all salaries are below around $90,000, and half of all salaries are going to be above $90,000. That's what that middle line represents. It's the median. Now let's talk about that actual box. This is called the interquartile range, or IQR. And IQR defines the box width, and it's essentially the middle 50% of all the data points. So 50% of all the data points are inside this box that falls between Q1 and Q3. And it's called IQR. So Q1 is the 25th percentile, essentially separating the line for the bottom 25% of all the data points versus everything else. So 25% of the data points then are below Q1. These are the 25% of the lowest salaries in the dataset. Q3 is the 75th percentile, which means the highest 25% of all data points are above Q3. The whiskers themselves are in general defined by 1.5 times IQR. So you have this interquartile range between the 25th percentile and the 75th percentile, and then by convention those whiskers are going to extend by 1.5 times the IQR. And then by convention we also define that anything outside of this 1.5 times the IQR range are going to be labeled as outliers. So the box plot can quickly give statistical distribution information in this visual format. Keep in mind, it can also be oriented vertically or horizontally. So then that means we can create a box plot per category. So now I'm displaying the box plots for all the levels of education. And now I can directly compare distributions across categories. note I could also flip this so that the actual categories are on the x-axis and the y-axis is going to be the continuous variable that I want the distribution for. Something that's really important to keep in mind here is that what is not being displayed is the count per category. So while you can see that master's degree looks to have very low variance and everyone more or less has the same salary there, what is not actually being shown is that there are a lot less people with a master's degree versus the other levels of education. So it's not really clear to me just with this box plot set that there could be 1,000 people in some college and just 5 people with a master's degree. Or in theory, it could be the opposite. We could have just 10 people of some college and thousands of people of master's degree in a very narrow salary range. The box plot is not reporting that. It's simply reporting the distributions based off those statistical estimations of those quartiles. So let's discuss the violin plot, which plays a similar role as the box plot, but what it's going to do is it's going to display the probability density across the data using a KDE. Now we already learned about the KDE, so how does this relate to a violin plot? I like to imagine this as a mirrored KDE plot, which is essentially all it is. So what we're going to do is let's go ahead and take the KDE of a single feature, such as the salary again. Here, I can see the KDE for the salary. To construct the violin plot from this, what we do is we mirror this KDE and then we join it together. And it kind of looks like the body of a cello or a violin, which is where it gets its name from. And so essentially when you call violin plot with Seaborn, you get something that looks like this, which if we again just construct this, it's the KDE plot being mirrored and joined to itself. So there it is. Okay, and again, you can notice that there's a little white dot in the middle. That's actually going to be the median. And then you'll notice that there's a box itself within this violin plot. That is the interquartile range for the violin plot. So keep in mind, it's actually showing you a little bit of the information from the box plot itself right there in the middle of the violin. But then what it's also going to do is show you the KDE curve for the distribution itself. And so of course then I could have violin plots per category. So here I can see the salary per division being worked in, whether you work in printers, peripherals, office supplies, etc. So we can see there's kind of like a little mini box plot at the center of those violins. So now let's talk about the less common ways of actually showing distributions across different categories. The first one that we're going to talk about is swarm plot, and then we'll talk about box-in plot or letter value plot. The swarm plot is actually really simple, and all it does is it just shows all the data points in the distribution. Keep in mind, if you have a very large data set, it's actually not going to be able to show you all the points, and instead Seaborn's going to warn you that you're missing a certain percentage of points. But what it will do is it's going to selectively display the points so that you do get to see the general distribution of them. So what does this look like? Well, here are actually all the salary data points, and what we end up doing is we just plot them all, and what it ends up kind of looking like is a violin plot. And something to note here is that this actual swarm plot is not a mirror image. Instead, we are more or less trying to balance out where to place the points so that it looks like it's mirrored. But if you can see here, especially on some of these outliers, it is not a mirror image. Instead, it's just one dot per data point, and that's the swarm plot. So then I could have a swarm plot per category. So essentially now I'm just showing all the salaries per employees and where they fall. So this is a way of kind of just showing as best you can the raw data information. And so what's nice about this is this will actually display how many people I have per category, which the box plot and violin plots weren't actually able to tell me. So again, we had that issue with the box plots where I didn't know if I had 1,000 people with master's degrees or just 5 people with them. But here I can see exactly the amount of dots I have per category. So it's trying to further balance that out and fix that issue. And if we do have an issue where I have a lot of data points, I can always change the size of the points to try to display more and more points on the screen. So let's talk about this final plot. The box-in plot, officially known as a letter value plot, is actually a relatively new plot developed in 2011, and it's also a relatively new addition to Seaborn. So it was developed by Hoffman Kafadar, and Wickham. Hadley Wickham is a famous developer for the R programming language. And the main thing to note here, it's designed as an expansion upon the normal box plot. We're not going to dive into the very details of how the letter value plot is constructed. Instead, in the lecture notebook, we linked to the official paper that goes through all the math of how it actually creates the boxen plot or letter value plot. It's outside the scope of this course to kind of read the paper out loud for you, but it is linked for you in the notebook if you end up using this plot. So the last thing I want to note is that the boxen plot call for Seaborn is so uncommon that if you were to Google search boxen plot, Google's actually going to autocorrect and think you're talking about a box plot. So you should really only use this plot type if you know your audience is familiar with it. Do not use it just because it is a cool plot to use. While it is a very informative plot, and I do think it's a better plot than the box plots, the whole point of visualization is to clarify things for your audience, not confuse them, or have to give a half-hour presentation on what the visualization is before you actually show them the visual. So keep that in mind. Okay, so what is actually happening here with the letter value plot? It essentially uses a system of letter values that you can use multiple quantiles, not quartiles, quantiles, instead of strictly quartiles. So what it does is it automatically calculates multiple quantiles based off how many points you have and their distribution. So essentially what we have here, and these are images from that paper that is linked for you in the notebook, is that the boxen plot is showing the actual distribution with quantiles instead of just strictly quartiles. So it's actually able to kind of show you more boxes to try to blend the difference between a box plot and a KDE. So you can see here in that top row, those are the regular box plots. And for these particular distributions, it's kind of hard to actually read what's going on here. For example, the first one shows a very narrow band for the actual box itself and then lots of outliers. So that's better displayed with the boxen plot, which instead of just using quartiles, separates it out into multiple quantiles. Then you have all the way on the right, the many outliers falling outside of the IQR range. And so here the boxen plot is trying to show you through quantiles the actual distribution. And again, here are more examples of use cases where a box plot is probably a poor decision versus the boxen plot, which tries to actually clarify that distribution. So this is available in Seaborn for you. Again, it's showing you with quantiles outside of the regular quartiles. So it's kind of giving thickness to the whiskers in the same way that you get data for the box right in the middle of the plot. So I keep mentioning this, but this is a very unusual plot. I myself have never actually seen it out in the wild for a business presentation, so to speak. So you should always be careful with this sort of plot because someone reading this would probably most likely at this point in time not actually know what kind of plot type this is. So just keep that in mind. Okay, so after all of this, we want to constantly keep in mind that the main purpose of data visualizations is to inform, not confuse or show off the really cool esoteric plots that you know. So in the next lecture, we're going to explore on coding out all these plot types with Seaborn. I'll see you there.